is a very successful serial entrepreneur for over 25 years. He's a bit of a hardware guy, is that right? Come on up. This is Rick Blazinski. His expertise is in system on chips, microprocessors and networking, and now he's with Splend. And today, he's going to talk about a blockchain network infrastructure company and what blockchain network infrastructure is. So over to you, Rick. Welcome.
Thanks, Keith. Hi, thanks, Keith, for the introduction. And we are here today and so fortunate to have someone like Tim Drapers that are so supportive of the blockchain growth and development. And let me just tell you a little bit about myself. My name is Rick Blazinski. I'm the CEO of Splend. I'm a serial entrepreneur. I've been in the Valley long enough, about 40 years now. I've seen this valley transform from Orchard Valley to Silicon Valley. It's one of the greatest places to live today. Along the way, I've created numerous successful companies, and the first one was in 1995, and the name of that company was Softcom Microsystems. We implemented, we created, we architected, and we deploy, along with some of our partners, one of the greatest, biggest, largest intelligent pipe for the internet. And this deployment is part of the internet infrastructure's deployment back in the 1990s. We were so successful that 4 or 5 years later, Intel Corporation decided to acquire Softcom. And after that, I started another technology company. It's called Bay Microsystem. Again, similar to Softcom, we architected, implemented, deployed the large internet smart pipes. And I call it smart pipes because it's very difficult to do a smart pipes. And when we founded this type of companies, we can't just increase the performance by 10 or 20%. We have to leap forward orders of magnitude to make a difference in the internet infrastructure. Along the way, I have filed and been granted several patents, and most of them are in the broadband networking as well as network processors. So that's pretty much what I just summarized. Today, we're going to talk about innovation, renovation, solving the scalability issues in blockchain. But more importantly, solving the scalability issue is not the end of the road. We have to go forward. At the end of the day, we have to reach mass adoption. And I will talk about that later. So most of us have similar visions. We have the blockchain, we believe that it's going to be larger than the internet. The internet is one of the greatest inventions of all time. And it's going to be challenging to beat the greatest inventions of all time. So, what makes blockchain great? As Tim said before, decentralized, we have peer-to-peer, immutable, we have censorship resistance, and all these good attributes. But one of the key reasons why that blockchain is so disruptive is that it's transforming the internet, which is one of the greatest inventions of all time, into the new global network of trust. Now, what does that mean? The new global network of trust. Some of you know we don't need to rely on anyone when we are transferring Bitcoin or working with some kind of smart contracts on there, transacting with all this different intelligence in the blockchain. But global network of trust. So who do we trust? Who do we rely on? We rely on the cryptography behind the blockchain protocol and consensus algorithm. I will talk a little bit more about that in the next few slides. So that's who we trust. We trust the cryptography. And what is cryptography? Modern cryptography combines mathematics and computer science. That's the new law. The code is the law, the cryptography, and that's who we trust. The global network of trust. So before we move forward and look at the scalability issues and solving the scalability problem, let's take a look at how did we get here in terms of the internet. Again, I keep repeating this. It's one of the greatest inventions that we have. So how did we get here? First, it's the standards and protocols. Standards and protocols have been around for decades. We have, today, we have standards for various different parts of blockchain. They make sure that we interoperability with each other. And standard works on application layers, middle layers, lower layers, all layers. From the applications all the way down to the optics. And yes, the standard bodies are working on blockchain in some form or another. So the second one I have is advancement in microprocessor technology. To be specific, advancement in semiconductor technology. If you look at the Intel processor that came out first in 1971, it's the 4004. That processor has about 2,300 transistors. Today, if you look at the A11 chip inside the iPhone X, it has 4 billion transistors. And that is truly a piece of art. How you can squeeze 4 billion transistors in this amount of space, this amount of density. So we have the standards, we have the advancement in microprocessors and semiconductors in general. And if you combine those two and look at what powers the internet, it's all this system level integration. What system powers the internet? We have the switches. There are many different kinds of switches. We have the routers. There are the access routers, edge routers, backbone routers. We have the cable modem, mobile switching equipment, firewalls, storage, servers, all of these devices. What do they have in common? They have millions of lines of codes and billions of transistors inside them. You have to integrate software and hardware. And that's how we get here today. System level integrations. The standards are all working on all the different layers of protocols. The advancement of semiconductors. And that's why we are here today. So let's take a look at Innovate or Reinvent. So what do we need to do? I think we need to do both. And even more. It's probably enough, it's probably not enough, but we have to do more. So let's take a look at this funnel. I call it the funnel problem, the funnel dilemma. Tens of billions of dollars have been spent today in thousands of blockchain companies. A lot of companies work on the decentralized applications, which is at the very top of the layers. And that's very important because that's the one, the apps is the one that interfaces to all of us, whether it's IoT devices or users like us. And below that, if you look at the protocol layers, a lot of great blockchain companies, some of the best engineers, scientists, and researchers, they are working on solving the blockchain scalability problem. As you know, Bitcoin is great, but the proof of work, the consensus layers that is inherent within the Bitcoin protocol is very compute intensive. And it took a lot of electricity to mine Bitcoin today. So some of the greatest researchers, the amount of cryptographic research today is unprecedented. And one of the reasons is because of solving the blockchain scalability issues. But are we going to stop over there? Let's take a look at another layer down. It's called the P2P overlay network layer. What is that? That's another level of complexity. You know, over here it's simplified. It's only one layer, but there is a lot of sub-layers inside there. So you're basically virtualizing the physical networking layer underneath and virtualize it so that the applications at the higher layer, it can be easier for them to work and you don't have to know the detail about the networking layers. Now, as we all know, when you start adding layers, you're adding complexity, you're adding inefficiencies, you're adding layers and layers of codes, and you're slowing the process down. It is necessary to have the P2P overlay networking layers. The various distributed hash table that you keep the hash of a content, and you're actually transforming from a content addressable mechanism instead of location-based addressing. So, but you have to do another level of mapping, and that's another layers that we have to deal with. If you go down one more layer, which is the networking layer, TCP/IP, OSPF. Now you have to really deal with reality, because the reality is, depending on which date you want to start with, I think January 1, 1983, that's when ARPANET was spin off and be commercialized. And that's 35 years ago. So give and take, TCP/IP was founded 35, 40 years ago. That's an old protocol. Yes, it has been improved over the years, numerous improvements, but at the end of the day, it's still a 35, 40 years protocol. And you know what? We have to live with it. It's not going away anytime soon. So, the goal of solving the scalability issue of blockchain, we have to look at every single layers, all the way down to the lowest level, because we really want to scale this to billions of users and devices. And what I mean by users and devices is users are billions of people in the world. What about devices? IoT devices, that's tens of billions of them. And these devices are going to interact and triggering messages to smart contracts and so forth. So we really have to look at all the layers. Now I'm going to magnify the problem a little bit more right now. We just saw a variation of this slide a while ago. The standards are good. They're all working on all these protocols, all this wonderful stuff. But what happened to the advancement in semiconductor? So this is some of the quotes by one of the greatest professor in computer architecture. He told us 2 weeks ago that we are beyond Moore's law. We are living in a post-Moore's law era. What does that mean? That means we take it for granted. You know, for the last 2-3 decades, 2,300 transistors goes to 4 billion transistors. Because Moore's law, hey, you can double the performance of processors or the density of memory in 18 months. Well, that's great. But according to Patterson, one of the greatest professors in computer architectures, that's no longer true today. So we can't just rely on Moore's law that we took for granted that, hey, if this is slow today, just wait another 12 months, 18 months, things will be okay. Processors, memory are going to solve our problem. No. He observed a single program increases only 3% in 1 year. And that amounts to doubling in 20 years. I can magnify the problem again at the network level. Just to give you a little bit of a perspective. At 10 gigabits per second Ethernet, we have to process 14.88 million packets per second. Okay, let me put it another way. So, how much time do we have to process a single packet? 67 nanoseconds. At 100 gig, 6.7 nanoseconds. And the layers are become more complex. As you go from the networking to the overlay to the consensus to the protocol layers and the applications, it becomes more complex. And yet, the processing time for each packet becomes less and less. So what do we have to do to solve the scalability issues in blockchain? We have to make the funnel into a cylinder. We have to look at every single layers and expand these layers so that we can scale all the way from the application layers down to the lowest layers. Make the funnel into a cylinder. If you look at today's internet, It seems simple today. It's a 7-layer ISO that was defined by ISO. It wasn't that trivial when we were developing the infrastructure for that. But if you look at that today, look at what happened at the higher layers. They all changed to new protocols. We have Ethereum, EOS, Ripple, Corda, Hyperledgers. We have all different kind of proof of stake, proof of work, Byzantine fault tolerance, many different variations of proof of stakes. And yet, they're still running over the good old TCP/IP. It's not going away. So, the message here is that to scale to billions of users and devices, we have to expand at every layer. So, scalability, yes, we have to solve scalability issue. We have to solve the funnel issue. We have to solve the Moore's law that we've been relying for a long time. But is that enough? No. Why is that not enough? Over the past few decades, I have seen quite a few brilliant, excellent technology, protocols that we work on with the standard bodies for over a decade. Thousands of companies and billions of dollars that this company poured into that technology and protocols. Did it scale? Absolutely, it scales. But you know what? It didn't reach mass adoption. And yes, we have to work in blockchain to solve the scalability issue. But we have to cross that bridge from early adopters to mass adopters. And that is very important because I've seen some technologies that are so good, billions of dollars, tens of years, work on it, thousands of companies, scale. They stay in the shelf. They're not here. Today, we're using technologies that are not even as good as some of those technologies that are on the shelf. Okay? So, talking about mass adoption, we right now are working on a very large project, and this is a real project. This is one of the largest cable TV network in the world. It reached over 200 million households. They want to put all of the best technology, including blockchains, and use the benefits of blockchains. But it has to scale. It's over 200 million households. I'm talking about households. If you look at each household, let's say 3 or 4 family members, that's 600 to 800 million potential users in this one project right here. Of course, we can't do it alone. We have to have alliances and other technologies and integrate this, integrate that, and work together to realize this. This is the mass adoption case I'm talking about. In addition to this, I was in Asia for a couple of weeks, returning last week. The interest level is humongous. I had the chance to talk to large corporations. It was in China, Japan, and Southeast Asia. I had the chance to talk to large corporations, huge social organizations, and various different governments. And we are in the initial discussions of several other examples of mass adoption projects. We at Splend today, we continuously looking at various different technology, business partners, complementary piece of technology that we can together work to realize the mass adoption. So at the end of the day, where do we go from here? It's all about the users. Thank you very much. And we do have a booth outside. I'm very happy to be here and would like to meet some of you and answer any questions you may have. Thank you.